So this is the setup we have. We have mounted our ultrasonic sensor, the 1300 model, and for the sensing object we are going to take this box, and the scale will be used like a reference for the measurement distance. I'm also using Autonics ADIO, to which this ultrasonic sensor is right now connected. I'll just rotate my camera to show you the same. So this is the Autonics atIO-Link master, and this atIO-Link master I have connected to my PC using the PDCT cable. PDCT cable has the other end as USB, so I can directly connect it to my laptop. We will be accessing this ADIO through atIO-Link, and we will be checking the IO-Link parameters of this UTR series sensor. Okay, so to start with, we will click to add the ADIO, which is atIO-Link master. It has taken automatically the COM port. So whenever you open this up first, okay, you need to configure each and every port configuration. So this can be used like a maintenance tool to check the device status, to check the sensor status, to check the sensor variables, and set the modes of the sensors also. So we have connected our sensor to port 0. Hence at the port 0 we will configure the port 0 in atIO-Link auto start mode, and we will browse the IODD file which has been downloaded from Autonics website for the UTR series. I have downloaded the file and I have extracted the file at a particular location, which after browsing you can come to this stage. Click to open the file. Click on the file, verify the device name whether it is matching as per your model number, and select the IODD file. After selection, apply the settings to this respective port, and we can see now the port status is operatable and it is communicating on COM2 bit rate. So now we can go inside the port, and we can see through IODD file it has taken and read all the IODD specification here. We will go directly to the parameters. So first is the identification menu. You can read all of these parameters and you will get the vendor name, product details, serial number and all. Then in the observation menu we have temperature diagnosis. So here you can read the parameters to check the sensor temperature, the heating up phase, whether it has been completed or not. So I'm using the device right now for about an hour or so, so it has completed 30 minutes, for which it is showing me the heating up phase has been completed. Then going forward we have the measurement data channel descriptions. So blind zone is 115, setting zone is maximum till 1300. Okay, unit code, that means we are working on Okay, then let's look at the next parameter group, which is process data input. So the process data input right now has 220 value. We can also see, okay, so we can see the distance at which the object is at is almost around 220 okay, and hence we are also able to read as 220 in the device. Okay, then we have the scale flag, which is we are reading into reading, and then we have the analog status flag, active, and digital status flag. Then we have UOT diagnosis. So the sensor diagnosis, which is saying that the operating time right now, the sensor's operating time is almost 5.5 hours. So it has been used for 5.5 hours almost. User operation timeout flag is false. Okay, so there is a set user operation timeout that can be set inside. So which is this, which is at 1 lakh hours or something. So if this value is less, say if I put it 5 hours and write, so 5 hours has been written inside. Now if we go to UOT diagnosis, read the operation timeout flag, we can see the timeout flag is 1. Okay, because it has crossed 5 hours. So the operating timeout flag can be used in such a way. Okay, so I'll write it back to 1 lakh hours. And now if we go back to the UOT diagnosis, we can see the timeout flag has been resetted again. Then in the parameter menu, we have teaching mode. So you can select the kind of teaching mode from here, and you can manually do the position teaching, or if you require, we can also do the teaching by giving the specific position values instead of manually keeping the object and teaching. In that case, we can go to digital output, and from here we can do the teaching and we can get the parameters in detail. Like we can select the mode, how we want to teach. Say for example, if we take an window mode, you can use the window set points, window set point 1, window set point 2. Let's say if I take window set point as set point 1 as 200, set point 2 as 300, and keep the digital output mode as normally open, then in between 200 to 300 the output will be high, and outside this range the output will become low. But there will be also hysteresis present at set point 1 and 2. That is nothing but window near hysteresis and window far hysteresis. This we will keep it 5 mm and 5 mm at near and at far. So let us write these parameters into the device. And now if we look at the process data, we have set the set point 1 to 200 and the maximum to 300. Our object is within the sensing range. Okay, hence we can see the digital status flag is high. But if I change the object position, okay, say to 200, still it is active. Why? Because of hysteresis. So my hysteresis was 5 at both near and far limits. So if I go below 95, 195, we can see the output turned off. The output now will remain off below this range. Output will turn on at 200, and the output will stay on till 300, as our set point 2 was 300. So it is staying on till 300. So it will turn off at 305 because the hysteresis was 5. So we can see 5, it turned off. Okay, and it will again turn on at 300. Okay, so that is the window operation mode. Likewise, we can do the selection of mode here of any of these different types, 1 point or area, and for each of them there are separate set points and separate hysteresis parameters available. Also we have over here delay parameters, which is right now off. Say if I turn the delay parameter as on delay, and say for on delay time, if I set the on delay time to 5 seconds, write it, we can see the respective behavior, okay, in process now. So we can see the digital status flag is off, the digital status flag is on because we are within 200 to 300. If I go outside the range, the status flag turned off. Now when I go inside the range, that is at 300, so when I reach 300, we can see the output didn't turn on instantly, but it will turn off after a delay of 5 seconds. So after 5 seconds, the output became active. It is turning on. So the delay can also be used here. Similarly, we also have the analog range settings. Near and the far limit can be set here. Okay, so near limit you will get 4 milliamps, far limit you will get 20 milliamps if you are keeping it in rising mode. If you change to falling, then SP1 will correspond to 20 milliamps and SP2 will correspond to 4 milliamps. Likewise, the selection of current and voltage will be available here, but since this model does not support voltage, we are only seeing current here. Okay, I'll show you how the working of analog flag works here. So let's say if I put the near limit as 150 and the far limit for analog say as 250, so at 150 we will get 4 milliamps, at 250 we will get 20 milliamps, and the analog status flag will remain on within this time. If I go outside this range, then the analog status flag will turn off. Let's write these values and let's look at the process data now. So our value is 200, that is we are within 150 and 250, so the analog status flag is true. If I go beyond 250, we can see the analog status flag turned off. If I come back again within the range, the status flag turned on again. At the near side, if I look, if we go to 150, okay, and less than 150, analog status flag will turn off. If I come back to 150, analog status flag will turn on. Okay. Then we have the foreground suppression. Note the foreground suppression range and the analog set point 1. So analog set point 1 cannot be set less than foreground suppression, or foreground suppression cannot be set more than analog set point 1. So if I have set over here 150, I cannot set foreground suppression more than 150. Okay. So from 120 to 150 I can use the foreground suppression. Say let's here if I write 130 as the foreground suppression, and if I write it in process data, if you look, okay, yeah, it is measuring 150, 140, 130, but foreground suppression is 130. So below 130 if I go, it will freeze the distance value to 130. It will not change it. See, it has freezed the value to 130. Then we have filter options here. This filter options, we have foreground filter, averaging filter, foreground averaging and background averaging filter, and for each of these filters we can set the strength of the filter to be required. Okay, so these filters are used based on applications, that is if measure distance is more than the actual, we use foreground filter to extract the foreground data. If the the readings have lot of vibrations, the readings are unstable, fluctuate a bit, we can go with the average filter to smooth out the readings. And if the values are fluctuating and also the value is suddenly rising, that means the distance more than the actual is being shown, that means it is detecting some kind of background instead of the object in the foreground, we can activate foreground plus averaging filter. Okay, vice versa, if there are fluctuations in readings and the device is detecting a foreground object instead of the background level, actual level, it could be a scenario that a tank is having an agitator and we need to measure the level below, and the agitator is rotating at a slow rate. So when the agitator comes forward, we don't want our readings to suddenly decrease or suddenly the level to increase. Okay, the agitator which is in the foreground should minimize the actual reading disturbance. Okay, so in that case we can go with the background averaging filter. Okay, and each of these filters are having filter strengths from 0 to 9. Then one of the important parameter is the detection width. So there is setting available for wide, middle and narrow. This setting would only be available for 1300 mm model and 8 meters model. For the 350 mm and 600 model, we do not have this setting availability. So as per the application requirement, for say 1300 mm model, we can go with the wide, middle or the narrow beam settings. Okay, and using this we can avoid the sideways echoes that may result because of unwanted sidewall detection during any process. So this detection width data will be available for 1300 as well as for the 8 meter model.